Today we're going to take a look at characteristics of a parabola. Here's an example of a quadratic function. We know this is a quadratic function because of this squared piece right here. Even though this is called a quadratic function, its graph is called parabola. A parabola either looks like a U that's facing up or a U that's facing downwards. We're going to take a look at some vocabulary. First, we have to decide if this graph has a maximum or a minimum. It will only always have one of these. A maximum is the highest point on the graph, and a minimum is the lowest point on the graph. If we look at this, we have a highest point on the graph, but if you notice, these arrows show that it's going downward forever and ever. So there is no minimum, there's no lowest point on the graph. The highest the graph ever goes is right here. This is the maximum, and the value of the maximum is y equals 4. 1, 2, 3, 4. The value of the maximum is y equals 4. We also have to decide if this graph is positive or negative. Positive means the parabola opens up, like a smiley face. Negative means it opens down, like a frowny face. If we take a look at this, it is opening downward. Another way we can tell is by looking at the equation. That negative symbol means that the graph is negative. It is a frowny face, so once again we say it is negative, opening downward. Then we have to think about the vertex. A vertex is the point where the graph changes direction. If we look at this graph from left to right, we travel up, and then we change direction, we travel down. We go from increasing to decreasing, increasing to decreasing. The point where the graph changes direction is right here at -4, 4. -4, 4. We can also look at the equation from our transformations. We know inside is opposite, so we go left 4, up 4. Left 4, up 4. -4, 4. Left 4, up 4. The vertex will always correspond to the equation and where it changes direction. If we take a look at the domain, the definition of domain is all of the possible inputs. We've worked with domain before. Remember, domain is the x values because those are the inputs, and it goes from left to right. If we take a look at this graph, even though these arrows are pointing down, they're also going all the way left and all the way right. We say all the way left to all the way right is x is between -infinity to positive infinity. These are the sandwich symbols we used. X is between -infinity and positive infinity, or we say all real numbers. The domain for all parabolas will be all real numbers. If we take a look at the range is all the possible outputs, or the y values. So going from down to up. If we take a look at this, we know it stops at the maximum at 4. And it travels all the way downward. Those are the arrows. So we say y is less than or equal to 4. It starts at 4, and it's less than or equal to, because there's a closed dot there, this symbol is less than or equal to 4. If we take a look at the y-intercept, that is where the graph crosses the y-axis. If we take a look closer, this is the same graph that I zoomed out a little bit to see the y-axis. The y-intercept is right there at 0, -12. If we take a look at the x-intercepts, we also call them roots, zeros, or solutions to this quadratic equation, this function. X-intercepts, roots, zeros, or solutions is where the graph crosses the x-axis. We call it zeros because this is the line y equals 0, and it's where it crosses. So here we have two of them. The first one is right here, and the second one is right here. This is x equals -6 or x equals -2. You may see it as -6, 0 and -2, 0. But when we talk about solutions, we say x equals -6 and x equals -2. To review this same graph, we have learned that we have a maximum at y equals 4. We are negative because we are facing down. Our vertex is where it changes direction at negative 4, 4. Our domain is all real numbers from negative infinity to infinity because the arrows are going left to right all the way. Our range is y is less than or equal to 4 because we can never get past 4 and we are going down forever. The y-intercept is where we cross the y-axis at 0, negative 12. Lastly, our x-intercepts, zeros, roots, or solutions, they all are different words for the same meaning. That is where we cross the x-axis, and we can see we cross it at x equals negative 6 and x equals negative 2. That completes our first example. We're going to take a quicker look at example 2 and example 3. Here we have a function x squared minus 4. If we think about our transformations, we could see that it's been shifted down 4 from the parent, which is true. If we look to see if this has a maximum or a minimum, we see that this is the lowest point on the graph, and it goes up forever and ever. So we do in fact have a minimum, and we have the value of the minimum is y equals negative 4. Negative 1, negative 2, negative 3, negative 4. That's the lowest point on the graph. To determine if it's positive or negative, I see that we have a smiley face. So the smiley face means that it's facing upwards and it's positive. Remember, the vertex is where it changes directions. In this case, we're going decrease to increase, down to up, and it changes right here. This is the point 0, negative 4. The domain is where all the possible inputs, so traveling left to right. If we look at this, we have these two arrows. We're going all the way left and all the way right. Even though we're going up, domain is about left and right x values. All the way left to all the way right, the domain is negative infinity to positive infinity, or all real numbers. For the range, we have it's going all the way up, but it starts at that negative 4. So everything is bigger than that value of the minimum. So for our range, we say y is bigger than or equal to negative 4. This symbol is bigger than or equal to. It starts here and goes all the way up forever and ever according to the arrows. The y-intercept is where it crosses the y-axis. It is also the same as the vertex in this case because it rests on the y-axis. This is the point 0, negative 4. Lastly, we want to see where our solutions to this quadratic function is. These are the x-intercepts, zeros, roots, or solutions. And they are right here. These are x equals negative 2 and x equals positive 2. If we take a look at one more, we have this function right here. We see there's a negative. We see x minus 2 squared. So we have right 2 plus 1 is up 1. Right 2, up 1. If we start at 0, 0, right 2, up 1. Right 2, up 1. And that is from our transformation unit from last week. We have to determine if we have a maximum or minimum. We have the highest point on the graph. It goes no higher than this, so we have a maximum, and the value is y equals 1. To determine if it's positive or negative, I see a frowny face. That means it is negative. It's facing downwards. If we look at our vertex, we want to know where it changes direction. In this case, it travels up to down, changes from increase to decrease. The vertex is right here, and that is the point 2, 1. Right 2, up 1. 2, 1. It corresponds to this right here. Inside's opposite, 2, 1. Positive 2, 1. The domain is all the possible inputs. So if we look at this, we're traveling all the way left and all the way right. The domain for all parabolas, all quadratic functions, is negative infinity to positive infinity, or all real numbers. For our range, we see we have a maximum. It starts at the maximum and goes all the way down forever and ever. So it starts at 1 and goes all the way down. So we have y is less than or equal to 1. We have that equal to because it's a closed dot. Y is less than or equal to 1. Goes down forever. Our y-intercept is where we cross the y-axis, and in this case it's right here, and this is the point 0, -3. Lastly, we're going to take a look at our x-intercepts, or zeros, because it crosses the 0 line. Roots or solutions. These are where they cross the x-axis. In this case, we have 2. We have one at x equals 1 and another at x equals 3. Hopefully you've understood these vocabulary terms, and now you are ready to watch the next video.